Bismillahirrahmanirrahim. Assalamu alaikum. My name is Ramla Afzal and I am from BS Chemistry. Today, the topic of our practical is determination of iron in tablets spectrophotometrically. First of all, the purpose of this practical is to become familiar with principles of colorimetric analysis and to determine the iron content of an unknown sample. Coming to our summary, iron 2 is reacted with ophenanthroline to form a colored complex ion. The intensity of colored species is measured using a Spectronic 301 spectrophotometer. A calibration curve is constructed for iron 2. Its concentration of unknown iron sample is determined. The theory of practical is colorimetric analysis is based on change in intensity of color of solution with variations in concentration. Colorimetric method represents the simplest form of absorption analysis. The human eye is used to compare the color of sample solution with set of standards until a match is formed. An increase in sensitivity and accuracy result when a spectrophotometer is used to measure the color intensity. Basically, it measures the fraction of an incident beam of light which is transmitted by a sample at particular wavelength. You will see a spectronic 21 in this experiment. There are two ways to measure the difference in intensity of light. One is the percent transmittance, which is defined as in a formula. For any given compound, the amount of light absorbed depends upon the concentration, the path length, the wavelength, and the solvent. And absorbance is related to concentration according to Beer-Lambert law, where A is equal to epsilon BC, where epsilon is the extinction coefficient, B is solution path length, and C is concentration, and A is absorbance. Not all substances obey the linear Beer-Lambert law over all concentration ranges. Therefore, you will construct a calibration curve that will provide relationship between concentration and absorbance under the conditions used for analysis. In this experiment, you will analyze for iron by reacting iron 2 with ophenanthroline to form an orange-red complex according to following equation. Because we're starting with a ferric iron solution in order to be quantitative, all of iron must be reduced from ferric iron to ferrous by use of an excessive hydroxylamine hydrochloride. These are the safety precautions. The wearing of safety glasses or goggles is mandatory at all the times. Those students wearing prescription glasses must wear goggles over their glasses, and students without prescription lens must wear the safety glasses provided. And contact lens should not be worn in lab safety glasses or goggles. Procedure. The standard iron solution contains 0.2500 gram per liter of pure iron and pipette 25 milliliter of the standard iron solution into 500 milliliter volumetric glass and dilute up to the mark with distilled water. Prepare the following iron calibration solutions by pipetting the indicated amounts of above iron solution and into labeled 50 milliliter volumetric flask, and the flask is blank containing no iron. This is the concentration of iron and this is volume to pipette. Pipette 10 milliliter of an unknown sample solution into 250 milliliter volumetric flask and dilute to the mark with distilled water. Invert and shake the flask several times to mix the solution. Pipette 2 25 milliliter liquids of the solution into 250 milliliter volumetric flask labeled unknown using a 10 milliliter graduated cylinder and 4 milliliter of 10% hydroxylamine hydrochloride solution, 4 milliliter of 0.3% ophenanthroline solution to each volumetric flask. Swirl and allow the solution to stand for 10 minutes. Dilute each flask to mark with distilled water and mix well by inverting and shaking the capped volumetric flask several times. Using the Spectronic 301 spectrophotometer carefully, measure the percent transmittance of various solutions in 50 milliliter volumetric flask, including the two unknown solutions, and record your results in following table, including solution, transmittance, and absorbance. Now coming towards calculation and discussion. Prepare a plot of absorbance versus concentration of non-solutions. Express the concentration in milligram iron per 50 milliliter of solution. Draw the best fitting straight line through the points. This is called Beard-Lambert law plot. Place the best absorbance value of each unknown solution onto this plot and determine their concentrations. Calculate the amount of iron in unknown sample and express this as milligram of iron per liter of the original unknown solution. For example, from the graph, you will obtain a concentration of 0.10 milligram iron per 50 milliliter. Since in step 3, we diluted the original sample 25 times, and in step 4, 2 more times the concentration of original sample is therefore 0.10 milligram iron per 50 milliliter into 50 dilution factor into 1000 milliliter per liter is equal to 100 milligram of iron per liter. Compare your results with accepted values and calculate the relative error from this formula. And this is the graph we obtained. These are the references. Thank you so much. That's all from my side.